I guess then we'll start.
Maybe I'll just kick off. So I'm Dan Huttenlocher. I'm the Dean of the Schwarzman College of Computing. Came back to MIT about 3 decades after getting my PhD here. And then a few months later, COVID started. So it's been an interesting trip. I've had the privilege and pleasure of working with Eric for, a decade or more now. Eric was CEO of Google at the time and Google was very involved in the Cornell Tech campus that we built in New York City, that I was leading that project. And then starting in New York and continuing after I moved up here, Eric and I worked on a book together with Dr. Henry Kissinger called The Age of AI and Our Human Future, which came out in the fall and, I guess November, so the very late fall. And we thought it would be fun to, in the MIT context, just have Asu Ozdaglar, the EECS department head and my deputy dean in the College of Computing, ask us some questions related to some of the kinds of topics we talked about in the book, and then turn it over for audience questions. So Eric, thanks so much for joining us here today.
Thanks.
Thank you. And Dan, you actually worked for me under my command.
I did.
For a couple of years as a visiting faculty member at Google, where we first met.
Yep.
And he became the dean of Cornell Tech, and which was really transformative. And I think that convinced MIT that he could actually manage, which he really is very good at. So your transformation here has been fantastic.
And that was actually 2007. It was getting to be a while ago. So it's more than a decade.
50, you should be good at math. 15 years.
Yeah.
And but what MIT is doing now, I've gotten to know MIT well enough to know that MIT is making the transition from a culture which is sort of obsessive about strange details, is my description of MIT, into some of these broader themes. And my first meeting here, I don't think I ever told you this, when Raphael, who's a fantastic president, said I should come by and visit, they presented me a project which was still being developed in Lisp. And I thought, okay, we need to update that a bit. So I think we've made some progress.
Great.
Yeah, we still love to obsess on the details, but the big picture is also super important.
Yeah. Well, I'm very delighted to welcome Eric to MIT today and have this conversation with Dan and Eric on a very important topic about, how AI transforms the human society. And I think this is a great conversation to have with 2 leading thinkers in this area who both bring a wealth of expertise and experience. And as Dan mentioned, they just recently wrote a book on the topic, which contains a very deep analysis of these important issues. But what I found most important about the book is it provides a framing and a language to really systematically think about these issues and ask the right questions, which is the most important thing to start with on such complicated challenges, but also it suggests paths forward. So we have a lot to discuss, but before we dive in, I just want to make sure to remind the audience that we would like to invite you to participate in this discussion. So if you're joining us virtually, you can submit your questions using the box at the bottom of your screen. Please do so. We'll try to get to as many questions as we can during the Q&A later. But I'll start with some questions just to set the stage and start our conversation, get our thinking together. The first one is a very general question, but there's so many answers. I'm just very curious about your perspective on this. And that is basically the difference between the public conception of AI, which is largely shaped by science fiction movies, and the AI as the people in the field, AI researchers, think about it. And you can also think about this as a question between difference between artificial general intelligence, AGI, and AI as we know it today, which is something you touch upon in detail in your book. So maybe we'll start with Eric. And
Dan and I can do any of these together. So if you talk to people about AI, they basically believe the following thing: there will be a female robot that will be invented that will slay all the men. and which actually may be a good outcome in some future human scenarios. But I try to explain to people that there's so many assumptions in that, and we have a roboticist here in the room. I'll let you decide or describe what is possible in robotics. But where we are right now with AI is we don't quite understand how to generate volition. We're very, very good at pattern matching. And Dan, of course, is a world-class computer vision expert, which is where this stuff came from. So what I like to explain is that the first round of this, which was 2011, 2012, ImageNet, which all of you know about, was really the triumph of the computer vision over the human vision people. And the computer vision fits in all sorts of ways. And Dan can describe the visual system and why it's still the primary source of progress. Vision is not the same thing as volition. It's not the same thing as objective functions. So my instinct, and Dan, you may, or I think Dan is generally more conservative than I. I write stuff and then he deletes it in our partnership. I never delete any of his stuff. It seems unfair. And so in my idea, what happens is we're going to get stuck in this pattern matching period. And we're going to build extraordinarily powerful systems, which we can describe. The language model work that's going on now is it's at a pace that's breathtaking. But that's not the same thing as you wake up in the morning and you decide to take a vacation, work on something new, learn how to play the piano, see a new friend. We're just not there yet. Dan?
Oh, and I think that's great. I think the thing I would add just back to the science fiction side is, fiction needs a good villain. It's very hard to write good fiction without some kind of conflict in it. And the notion of the machine as villain is something that's existed for a long time in fiction. And I think, in the days before AI was becoming a reality, it was much less relevant what the fiction said. I think today, people watch Westworld or whatever, that was out there, and that sort of fiction really informs what they think about the AI that they're interacting with every day, right? So you talk to Alexa or Google Home, and you just watched, some science fiction on streaming video. Just the temporal juxtaposition of those causes you to expect that the AI you're interacting with is going to interact in ways where this wonderful storytelling is being done. And I think, as Eric said, the key issue is that AI does not have volition, intention. It's really about perceiving the world and organizing the world.
And one of the problems with this narrative disconnect between the reality and what people think is that people are now not understanding what the problems that real AI will create, which I know you're going to get into in some of your questions. But what happens to jobs? What happens to fairness? What happens to geopolitics? And I think the most important question, which is Dr. Kissinger's question, was what does it mean to be human when there's an intelligence that's not like us, but really smart? How do we perceive ourselves? Sort of how we got into this.
Very good. Fascinating. It's very much is a good segue to my next question. And something you mentioned in a number of places in your book, and I'll read exactly your words. AI without significant fanfare or visibility is integrated into the basic fabric of human activity. And I found that fascinating. Like, it's shaping so many aspects of our lives, yet it's not visible. We don't know it. We depend on it, but we don't know it. So how is this change transforming the human experience and, things like human perception, cognition, interactions between humans?
Well, let's start with what's going on at MIT. And again, you all are the experts of what's going on here. But what I've reviewed is that systematically every aspect of MIT's research is being changed by the presence of these new algorithms. Presumably that's beneficial. Presumably that leads to faster drugs. You have this extraordinary success here with Jim Collins and Allison and so forth, which you all know about. So there's this enormous wave of progress that's going to happen. And people may or may not give AI the credit for the progress, but the progress is coming. And that's a good thing, right? It's a really good thing. So then the next question is, okay, so, and this is going to happen whether we as individuals choose it or not. There's too many people working on it, too many benefits. You know, let's say you're a Luddite and you don't want drugs to get better. You can't stop this now. It's going to happen. So then the next question is, what happens to society? In the book, we spend quite a bit of time talking about targeting. And Professor Madri and I were talking earlier about the Chinese work in regulation. This is shocking. The Chinese want to regulate stuff, and they're very concerned about micro-targeting, right? Very interesting. I think that's roughly what you said. And why would they be concerned about that? We don't really know. But that's an example where people are beginning to think, well, maybe this thing's just a little bit too powerful in terms of its impact on our society. My simple answer, and then Dan, you can, I think you agree with this.
Yep.
Think about if you were founding a social media company today. So you quit MIT, please don't do this. Form a startup, and in a year you have millions of users, and your job is to maximize revenue. You maximize revenue by maximizing engagement. The best way to maximize engagement is by maximizing outrage. Because outrage is the thing that everybody talks about. So here we are, and we go from MIT, which is perfectly rational, you know, engineering sort of scientific place, to a place where people just make shit up. Sorry, shouldn't say that, but you get the idea. And there's no limit on that. There's no way to stop that. And to be very clear, I don't know how to solve this problem, but that's a real problem that's coming from this technology. You know, if Alexander Graham Bell today were alive today, we would say, what do you think about the telephone? And he would say, I love it. And he'd say, well, when you invented the telephone, it didn't occur to you that criminals would use your phone. And he goes, no, I invented it for myself. So it's not like this is the first time when an invention from you guys got misused by humanity and required a response.
So as usual, Eric lays out these grand landscapes where there are so many things I could say. So I really liked this sort of distinction you made between sort of AI at MIT and places like MIT and AI in the world. So I think AI at MIT largely serves as a partner, right? It's something that we are deliberately using in more and more laboratories and more investigations across the Institute, you know, using machine learning modeling to help accelerate discovery in more and more disciplines. So it's really becomes almost a thought partner as you develop things. And so that AI partnership model is very deliberate, and it's one of the things we talk about some in the book. But then when you look at AI as used in most people's daily lives, including ours, I mean, at least the part of our daily life that isn't MIT, the vanishingly small part sometimes, you know, you're driving with a navigation system on, you know, you're deciding what movies to watch or what books to read because something pushed some recommendation at you. You know, if you're a social media user, you're being inundated in things. And all of these decisions are being made by algorithms, usually machine learning algorithms. And so that's the very sort of passive part where even us experts don't stop and think how much we're depending on these things every day, making decisions for us, sort of presenting an option to us that we just follow blindly without thinking about it. And so I think this contrast between AI as a sort of conscious partner in work, which we're very privileged at places like MIT to be able to do, and AI as sort of, you know, something that we passively comply with is a really, really important distinction.
And you bring up the recommendation engines. I think that the recommendation engines, which have really blossomed and have been very successful because of AI, are the first example of something where people are going to have to figure out how do you regulate them? How do you address whatever failure modes they have? And my guess is that countries will do this differently, and it will be done generally badly. right? So it seems to me that one thing MIT could do would be to try to figure out what happens after deep learning to change this landscape. There will be a point when deep learning is mature and the PhD topics are no longer as juicy as they are today. And then there's going to be something after that. It's always the case. So what will it be? And I think that's a legitimate mission for you two, right? Because you work in this space, to corral the smartest people in the world to work on.
Very good, very good. One thing I'm actually personally very curious, and I was very glad to see it also mentioned in your book, is basically to look backwards. It's of course very important to understand impact of technological change on society, and throughout history we've had many, important moments of technological change. You mentioned in your book that only rarely has technology fundamentally transformed the social and political structure of our society. I thought that's a very powerful statement. And why is AI different? Is it really much more transformative than, if you think about some landmark moments, agriculture, printing press, or even in the industrial technologies? Do you think it will lead to more fundamental social changes or consequences than what we had before? And is it the scale? Why?
I don't think we've had this kind of innovation in history in the following reason. Currently, at least as we understand it, AI is imprecise. It makes mistakes. It's generative in the sense that it can generate new things. It can actually have emergent behaviors if it begins to interact that are unpredictable. And the most important thing is it's learning while it's doing. So I'll give you an example, and we mentioned this in the book. You've got a 2-year-old, you give the 2-year-old a toy. The toy is AI enabled. The toy keeps the kid behaved and so forth. Well, the kid gets older and the toy gets smarter. So now they're 12, the toy and the child, and the toy says, "I don't like this TV show." And the kid says, "I agree with you." How do you feel about that? Okay. So you say, well, it's okay, the best friend for my kid is not a human, it's a robot, but I understand it. But remember that this toy is learning. So how do you feel if I then add its ability to learn something that we didn't understand, that it thinks is true, and it tells the kid? And what if it's wrong? Right? So now there's all sorts of rules in America around textbooks. So each state has a list of textbooks that you're allowed to show teenagers. As to whether they follow them is not the point. Right? So do we have to have a list of approved learnings for toys for kids? And they're not allowed to learn this. Well, can you imagine that debate? I just don't think we have even a framing for a technology so powerful that it does all of these things and it's learning at the same time.
I think, so first of all, I think that's a really compelling example. I did when you helped us craft it as we were writing the book. Eric's very good at saying, we need to understand this, and then not giving up. But I think one of the things about AI more generally that is so important that this example shows is its ability to perceive the world in ways differently than people do, and then to interact with people at a level that it can change how people are perceiving the world.
Right.
And we've never seen a technology like that.
It's the impact of what it's doing on the people that is different, right? Before that, we could sort of predict what things would do. The gun was invented, we understood it was for. Electric power was invented, we understood it was for. Transportation, we understood what it's for. What happens when it starts doing its own thing?
How about the fact that it's general purpose and, maybe it's not really a tool for something, but it's really across many, many problems, domains.
Well, there have been many general purpose tools in the development of technology, but they've been bounded by some physical limit or what have you. But because this is around intelligence, it doesn't seem to have a bound. So we had a big fight about this, and I gave the AGI speech, which goes something like, there's going to be, in the next 20 years, something which has human level of intelligence that's going to be as smart as we, incredibly flexible, and it's really going to put us in our place. And Dan said, no, Eric, that's wrong. What Dan said is, it's much more likely, and I think he's right here, that these things will not be human-like. They'll be very intelligent, but not like humans. They'll have their own logic. And what was interesting was I fought him over this issue for a while, and then I was talking to these people here, in fact, about essentially synthetic biology. And I had assumed that synthetic biology would build biological systems that are identical to current biology. But when you talk to your synthetic biologists, they say, yeah, we use the principles of biology, but they operate differently. They solve different problems.
Yeah, like to those of us like of your and my generation, where as students we had these little logic kits that we built stuff out of with electronic circuits, which now have all become pretty much solid state. They're basically building, essentially, in their view, in synthetic biology, they're building that kit of parts.
Right. But the important point here is that the process of designing these biological systems will look different than the natural biological systems using the same principles. We should think of the same thing will occur in intelligence. Now that is going to drive us crazy, because all of a sudden you're going to have this physicist computer thing that thinks the way a physicist does, but the physicists don't feel like it's physics, and the rest of us don't understand physics. We won't understand it either. Right? We're going to have to sort all that out.
I'm already there with the language models today.
Yes, explain this. Give some background on the language.
Yeah, so there are a number of these language models today that are trained on large amounts of text, and that can then produce extremely realistic-looking text from very, very small prompts. And one of the ones that we quoted in the book, because it was so striking with respect to sort of the nature of the capabilities of AI, is GPT-3, which has already since been surpassed by a number of other such systems, which was developed by OpenAI. And the sort of prompt was asking GPT-3 to talk about itself. And the sort of dialogue that it synthesized included GPT-3 saying, I'm a language model. I'm not intelligent like you are as a human. I can speak intelligently, but I don't actually have intelligence. All I have is a model of what human language looks like, and I can produce things that look like human language. And so what I find extremely frustrating already about these models is that because human language is such a powerful means by which we communicate our own understanding with one another, human to human, forget about AI for a minute. Two humans, what do we use to communicate our understanding? Language, for the most part. And so when something is very good at synthesizing powerful language, but doesn't really necessarily have an understanding that's driving it, that's something that I find insanely frustrating. And so
and I think it's worth building on this in the following way. So if you talk to the people doing research, some of whom are here in this area, first, those large language models are exploding. They're exploding all over the world. There's a race, if you will, in terms of scale and size of language models. The training cost of GPT-3, which is almost 2 years old, was about $100 million if you include the electricity and the computers and the people and so forth. The new ones are 10 times greater, and using engineering techniques, it's not going up linearly with the size of the model, thank goodness. And they're getting much, much better. The evidence so far is that the models get better with absolute scale. They're not seeing a mean reversion yet. They haven't hit some limit to how much they can know. So the strange thing about these language models is you train them and then you try to figure out what they know, which is the complete inverse of how programming is done. You typically know what you're doing. Well, here you train it and then this interesting things happen. And the most recent, there are two recent things that have gone on. One is that Microsoft has offered a series of products which are programming assistants. And the reason to think that's going to be successful is, first, you're always better off in computer science when you're building something for yourself, because then you get it right and you use it and you iterate with it. It's just the nature of the field. And second, you get a strong training signal back. When the computer proposes the next line of code and you say, no, that's wrong, it then puts that into its learning regime. So there are 4 or 5 startups that I'm aware of that are now basically trying to build programming assistants of serious power to do that. Now that's an example of a highly specialized intelligence. And you could imagine that eventually it could get to the point where you could say, write me a program that will generate a browser, and it will know enough to actually write the code. Now that's not the same thing as Volition, but it's scarily close to it. Another one is a product called Lambda, which was developed in the research labs at Google. The technical details were released this past week. And one way to understand it is they trained it on a relatively large corpus of human conversation. So it feels conversational, and it's backed up by a lot of data. This is Google, so obviously they have a great deal of research around search and answers and so forth. And you can ask it very complicated questions. So a predictor for the next 5 years in this is the models will get much larger. They'll be completely multimodal. That means text and video and so forth. And they'll get really good at summarization and answering questions. Now, I don't know what that means for businesses, or I can imagine businesses where that matters, but it has a big impact in terms of human day-to-day life. Because now you type in a query into Google, hopefully, and you see all these answers, and then you figure out which one is crazy and which one is correct and so forth. Hopefully Google gives you the right answer. This next thing, you'll just type your question, and then this summary will come out. And it's highly likely to be accurate. That's a big change.
Very good.
Yeah, and actually it points at an interesting sort of change that's been happening as these algorithms develop generally is sort of increasing homogeneity, sort of loss of heterogeneity. You know, the world in general, we benefit from the fact that we all have different views in this room. I'm sure I can find topics that we all disagree on, but algorithms tend to, so it'll produce a summary that given the particular query you gave, and there's more richness in the language model than that, but these things are generally, they'll take sort of the most likely summary given a particular query, as opposed to, at least today, even if you get a bunch of garbage back from Google, you see some of that heterogeneity. Mm-hmm. So this is, I think, another struggle that we have as AI gets better and better. And believe me, there's plenty of machine learning in what Google gives back today. It's not, but you still sort of play an active role. It's filtered a lot, but you still get some sense of what's there. When you start getting compelling sounding summaries, that may just be, okay, that makes sense. That's my understanding of the world. And so I think this is another, some of the broader philosophical questions that we tried to sort of investigate and raise in the book is some of these kinds of changes, if we don't think about them and we don't think about how AI is interacting with us, will substantively change how people interact with the world.
And I'll give you a simple example. When I spend my time in DC talking to politicians, if they're Democrats, I talk about utility functions and economic growth. With Republicans, I talk about national security, and I say the same things. But I understand my audience well enough to shift what I say in words and emphasis. When I was doing this, when I was at Google, I would go visit a country, and if the country would typically have a dictator and a number 2 that was not a dictator or vice versa, and I would say the internet will benefit you economically and growth, and the other one I would say that you need to do this and basically not talk about the openness that it invites. In another case, I would say this will be openness and democracy and all of that. I do this naturally. We all do. So when the system understands what your biases are, and the summary is no longer the same summary that everybody else gets, but it's tailored to you, that is another set of issues. So what happens is the moment that in computer science, remember, the moment something happens, then you have the problem of recursion, right? So there's always going to be a successor that uses that. So the ultimate outcome could be highly specialized narratives that are specific to you. You have no idea why it's specific to you because it learned something about you that may or may not be true. But nevertheless, you got it, and Dan got something different, and Asu got something different in and of itself. Who knows?
It's the much more omnipresent version of the annoying thing that, Netflix learns something about you that actually has nothing to do with your taste and keeps recommending all kinds of stuff you don't want to watch.
And when this started, the recommendation engines were relatively simple. I used to give the example when I was selling Google ads that the TV would show an ad for diapers, and there's no diapers in the house. Well, that's a wasted ad impression. It should know something about the house. Well, now in 20 years, we've gotten to the point where it knows everything about the house, right?
So just to follow up on some of the things you mentioned, I'd like to sort of focus on the pace of change and how we adapt to this, how we stay ahead of this. And you do, I think, I found it fascinating that you also go back and, similar to the previous looking backward that I talked about, you consider sort of the evolution of human thought around reason with lots of philosophical underpinnings and pioneering contributions from Kant to Wittgenstein. And then you sort of mention, I think, very much, and I'll refer to my notes for that, is that online platforms inundate users with opinions of millions of others, depriving them of the reflection needed to develop that wisdom and the social values. I sense an underlying worry or concerns about, how we're going to be, how our existing, philosophical constructs or societal institutions will be, whether they will be sufficient to deal with this change. So what are your thoughts on that? How do we deal with it? How do we, change our social government frameworks to be able to stay ahead of this change?
Yep. So I'm going to very carefully not answer this question. Well, just because so much of what we've been trying to do and the work we've been doing together is, as you noted, Asu, to provide framing for people to start to think about these things more. And I think, to me, the historical framing that's very relevant and important to your question here is, if you look at sort of evolution of human thought around the time period where in the West the movable type printing press moved us from a world where most people got information through word of mouth or from organized religion to where they could, literacy became more and more widespread and people could read what they wanted to and form opinions from what they saw published. And the huge impact on society was moving from a world where faith was the main way that people understood the world around them to a world where human reason and faith together were how people understood the world. And I think one of the big changes with AI, and we don't understand what it means yet, is that there's another change happening. That when you have another entity that is, similarly intelligent to humans, at least in some cases, that's going to lead to some other way of looking at the world. And it could be that we come to view, humanity at large comes to view AI as this omniscient oracle. And then it sort of becomes another kind of faith, right? So you move from faith to faith and reason to, faith, reason, and another kind of faith. Or it could be that, AI is developed in ways that people can really engage and can learn more and can become, much more educated interlocutors of the world around them, and in fact act to reinforce human reasoning. So I mean, there are very different possible outcomes that can come from how AI is developed, how humanity starts to use AI, and those kinds of broad framings I think are incredibly important and often, not what we're thinking about when we're deploying these kinds of technologies.
Let's leave it at that. I think that's good.
Okay, I'd like to move away from the worries a bit and then focus on the positives, like a new technology for the greater good to improve human lives and condition, and I know this is something you both care a lot about. What are some areas that AI will have the potential for immense positive change in the short term, long term?
I think we would both answer this with one word. It used to be plastics in the movie, now it's biology. Right?
Yeah.
One of my friends said that physics requires math in the same way that biology will require AI. The biological systems are so complicated and so incomputable, in Eric's terms, that the only way we're going to understand these complicated living systems is through the kind of modeling that AI. It's as though AI was invented to solve this problem. It looks for patterns, it looks for changes, it can do generative work. For every analysis that an AI system, it can generate an equivalently interesting answer. So here at MIT, you have many people who are using this to basically look at very complicated biological processes for various drug discovery and things like this. The halocene example, maybe you should talk about, it's a good example of how traditionally stovepiped industries have actually worked together as a team. And I will say further that I think here at MIT, every science project will have an analogous AI team with it. I think that's why Steve Schwarzman generated college. I think that's why you came here.
I think one thing you mentioned there that I would just underscore is that so many existing things that we use in scientific and engineering discovery are for analysis. And AI both enables analysis and synthesis. And so many problems that we're trying to solve in science and engineering, synthesis is a key aspect of the problem. So it really transforms the landscape. And I would agree that I see the biological and life sciences at the core of that, but materials and chemistry and other things are also very hard, and even parts of physics, frankly, where the math only gives you a very broad brush understanding of things, where ability to do analysis and synthesis with machine learning, I think, is really going to transform things.
Yeah, one of the things that's interesting is that the canonical model for AI research was you get lots and lots of data, you analyze it, real world data, so data matters a great deal, and then you come up with insights. Mm-hmm. So I'm sitting in a meeting at our research group that's studying the question of, for reasons that were never apparent to me, whether a mouse was sleeping or not. And it turns out that mouse sleeping is difficult to detect for reasons, again, I don't understand. And they couldn't come up with training data by measuring it. So they built a simulated mouse using normal mechanics, and they figured out how mice sleep enough, and then they generated the training data synthetically. And I thought that's like a violation of the first principle. The first principle is you have to have lots of training data. Well, these guys generated it. So I think the second phase of AI is that scientists are going to use the known principles of the world and generate the training information using techniques like this. And that will then drive both traditional learning, reinforcement learning, and so forth. There are some things that would be amazing. For example, if some of you could invent a universal simulator that could be used across all of these fields, that would make a big difference. Reinforcement learning requires a fast simulator because in reinforcement learning, you're looking at multiple forward paths and you're optimizing the choices.
I do think the power of simulation in machine learning is something that we're still only scratching the surface of with reinforcement learning.
I'll ask maybe one last question. We're running out of time. Unbelievable. I have so many more questions, but I'd like to also contrast some of these technologies and what we're experiencing with social media, a topic very, something we talk a lot about at MIT. I know, Eric, you're very interested in. What's the impact of AI technologies in that domain where it's, even more interesting because these systems help us, deal with this incredible amount of information, but at the same time, they learn from us, shape our behavior, and lead to very profound social, political.
Well, everybody saw the coverage last year of what are called the Facebook files, where internal documents were stolen from Facebook and leaked. And there was a big hubbub about that, regulatory hubbub and so forth. I don't know how that's going to get resolved. But there were a series of interviews with people who worked inside of Facebook, as opposed to people like me who just make stuff up about this. And they asked them, how would you actually solve this problem? And they said, go back to the linear feed. I said, that's interesting. So what had happened was, in the last 2 years, AI, who's a leading AI researcher, Facebook, a leading AI researcher, had amped up the feed using the signals to make it more impactful and so forth. And I assume that they did this legitimately and for good reasons. So that's a good example where you have a generally well-run company trying to do its mission in the world, and then they adopt AI, and then they get this huge impact and blowback. Maybe they didn't understand the impact they were getting, or maybe they misjudged the impact that they would get, but they're paying big time for it. So there's a current example, and I don't know how that's going to get resolved.
Yeah, I think social media generally is a very, the use of AI in social media today, don't fool yourself into thinking that today's social media could operate without massive use of machine learning and automated decision making. It doesn't scale. But I think the use of AI acts as a big amplifier of everything that humans do. What's good, what we view as good, what we view as bad, what we like about ourselves, what we don't like about ourselves. And I think, partly Facebook has gotten sort of caught up on, in making the feed be so much more driven by AI recommendation. They've gotten caught up in that amplification phenomenon. So some of the things that they're amplifying presumably are very valuable to their users, and that's getting a certain kind of engagement. And others are things where, various researchers at Facebook said, why are we amplifying this? And teasing those apart is not always easy.
I told you that I'm a simple principle. I'm in favor of free speech for humans, not for robots. Okay? So this amplification problem is very real. I'll give you another example, and this is from maybe 7 years ago at YouTube. YouTube would show a video of something pretty nasty, and the recommendation engine was so good that it would keep showing it. And there was evidence that this would drive people into terrorist or near terrorist activities. And so the way this was solved was the company defined a class of categories which were special, and they were not to be amplified. So if you saw one, they weren't censored, but they weren't amplified. So you could find it and you could watch it, but it wouldn't suggest another one. And furthermore, we wouldn't monetize it. So that's an example of a fairly crude and simple change that you could make, where you've got normal stuff and then, let's just say, on the edge stuff. There's clearly stuff that's illegal, but things which could be interpreted as recruitment videos for bad acts. And we had a process that would judge that. So that's an example of the kind of change that you could make. I don't think you're going to solve the problem in a fundamental way. And I think there's a project here looking at this. There's other people I know working on it. But until we come up with some new ideas, everyone involved in the content business is going to fundamentally have good content, questionable content, and forbidden content. Forbidden content you're not going to do, so child pornography, things like that. The questionable content, you're going to have to not monetize it. You're going to have to not recommend it. And then you, as the provider, can make a decision as to whether you want to host it at all. And under American law, those decisions are made by the private companies.
Mm-hmm.
So I would just underscore in the, not free speech for robots, that the point that you made, but I think that people often miss, and that's why I just want to underscore it, is that when a social media algorithm is pushing something at you, That's the robot speaking. It may be, it is some human's speech, maybe it was robot-generated speech to begin with, but assume it's some human speech, that's human free speech. But the fact that it's pushed at millions or billions of people is actually the robot deciding to speak. And that is a very complicated set of issues that we really need to address as a society.
Yeah, and then there's all sorts of complicated problems. We had one case where we were studying this. There was a person, this was his speech, but he set up a tweeter bot to tweet every hour, 24 hours a day. Now, he wasn't awake every hour. So is that a permissible amplification of his speech, or should you say he can only do that 2/3 of the day? You see, that's where the judgment comes in.
Mm-hmm. Very good. So I'd like to invite our audience for some questions. And, I think we'll have microphones that Eric has.
Hi, yeah, thanks for everything so far. In terms of artificial general intelligence, and actually a little bit of an analogy, the field of orbital mechanics made leaps and strides once people started making or questioning bad assumptions like circular orbits, and once people started asking the right questions, like what actually causes the orbits. So for AGI, what are the assumptions that we need to challenge, or the questions that we need to ask to actually make the leaps and strides in that field?
Well, I think one of the questions, since I'm pro-AGI and Dan is anti-AGI, okay, let's just say that AGI may be a destination we never get to. It may be a construct that defines the human progress toward these goals, so forth. Or it may actually happen. I don't think we know. So that's the first question. And I define AGI as the ability to generate its own tasks. Because that's the thing that, to me, defines human intelligence over other kinds of intelligence. There are other definitions. And how would you build a system using our kind of intuitive reasoning that could generate new ideas? The DeepMind answer, because I spent a lot of time with them, is that you can, using reinforcement learning, come up with predictable combinations which you cannot explain as to why they came up. And if you can't explain it, that's similar to human intuition. You know it, but you can't explain it. So that's that sort of religious pitch. But my judgment is we don't have an answer to the question of how do we go from these beautiful analytical systems, which are extraordinarily good, to where they generate their own activity. Do you agree or disagree?
No, I would actually agree.
So what is your time frame for AGI, Dan?
Well, I'm still back on your initial question of can it happen or not?
I think you see the problem.
Other questions? And while they're getting to that, I'd like to share something. My 9-year-old is very interested in AGI and reading your book. And I was actually telling him that, the difference between you, that Dan's time frame versus yours is different. And he looked at me and said, I agree with Dan, but I'd like to hear about Eric's perspective.
Well, let's see, if he's 9, his expected life expectancy is age 100. So in the next 91 years, I think Dan and I would agree that there'll be some form of AGI. Yes. We may or may not see it.
I will tell him that.
So your son is in a great position.
I'm still not sure it'll have its own motivation, but we'll see.
Where's the microphone? I can't see. Yeah.
So you guys mentioned AI for biology, and you guys also talked about sort of the increasing capital needs of training, state-of-the-art AI models, right? So the typical R0 grant amount is what, like $250,000 a year from the NIH? If you're a well-funded startup, you could raise what, $25 million in a Series A? Google just started their AI for drug discovery program where they could easily put, like $250 million a year into it if they wanted to, right? So it seems like AI research, even applied research in other fields, is sort of becoming capital intensive to the point where it could be antithetical to the principles of open research. Is this something that you guys could see challenging the development of the field in the future? It seems like a concern.
An incredibly well put question. And I'll give you an example of AlphaFold, which you understand how AlphaFold was done. AlphaFold's a huge achievement. AlphaFold was initially, the technical details of AlphaFold were not released. And now I'm no longer at Google, so I'll just say this without, I don't mean to criticize or praise. The Baker Lab watched the video of AlphaFold, reconfigured all of its stuff in some complicated way I don't understand, and then started to produce answers to human proteins. And then Google, then through DeepMind, released everything. So was it the competition with AlphaFold, with the Baker Lab that caused that? That's, some articles have said that, or was it just the lawyers slowing them down? Because corporations, lawyers slow people who want to open source things down. I don't know. But the important point is we got the information out. And understanding the protein that affects humans and their folding structure is a Nobel Prize kind of achievement, because it's like a huge platform for knowledge in biology. So my guess is you're going to see the usual mess. You're going to have corporations that keep it proprietary. You're going to have corporations that behave the way Google did, which is they release it. You're going to see private philanthropists, which includes me, that are going to fund these models. And then you're going to see other mechanisms. My guess is that some country, the obvious one would be China, will actually make this a national priority and will just publish it all. So I think it'll resolve itself. But one of the things that's different from 20, 30, 40, 50 years old is all of the progress is now occurring in these corporations because they have so much money relative to you.
But we're smarter.
Well,
No.
Dan, since we hired all your people, that can't be true. Right? We just transferred them from you to me.
No, but more seriously, so I agree with you that I think that this is a serious challenge. But I also think that when the research community gets focused on challenges, a lot of progress can be made, and important progress. And a big focus for a lot of machine learning work now actually is training with much smaller amounts of data, and in the reinforcement learning setting with much smaller numbers of iterations of a simulation. And I think this is an area that we can and will make enormous advances in. But right now we are in a whatever the opposite of a sweet spot is with respect to this. I do think it's a big challenge. But I think that there's already early signs of progress in a number of ways that.
But this is how it sort of happens,
Yeah.
right? You get this polyglot model.
Messy.
It's messy by design because of human creativity and maybe AI creativity in the future. But eventually there will be databases. There'll be a database of everything you need to know about this aspect of biology and a database of everything you need to know about this aspect of physics. And it'll be generally understood to be correct. And those become the platforms for the generation behind you, right? You're struggling through this strange problem of I don't have access to it, and these guys have it, they won't give it to me. But the next generation will have a common platform. That's how it always works. And that's the reason to be optimistic.
And more generally, I believe that constraints are a really important part of the creative process. And so, academics have to work on some different problems because we're constrained. We don't have $250 million worth of compute to put into something. And so these more efficient algorithms are something that we can and are working on.
And to show you my perspective, as a computer scientist who's been in the industry for a long time, I was reasonably convinced that universities were kaput with respect to this stuff, that we had simply drained all the talent, we'd taken all the money, and that there was nothing for them left to do in these areas. This is my own arrogance. Clearly, completely wrong, right? And when I look at the last 5 years of progress in science, astrophysics, biology, chemistry, material science, a whole bunch of fields in physics I don't understand, I listen to these guys' presentations, and they are world-class applications of some of these underlying concepts, and they're different. So I think we're seeing to be clear, I think we're seeing a renaissance in the universities. Now that the universities have got their act together, they got enough funding, people have a language, you see a certain amount of common goals, you're seeing it. It feels very different from 5 years ago. I don't know if you agree with my bias or not.
Well, to me, yes, I totally agree. And I think, part of what we're trying to do with the College of Computing generally is that computing and most notably AI have become part of the intellectual fabric, part of the way that people conceptualize problems in a whole wide variety of disciplines. And I think that there's still a lot to be done to make that easier across a wide variety of areas. But I think that this is definitely a golden age of that kind of transformation.
I mean, I'll give you a Caltech example. I first figured out the world was different than I said a few years ago when I was visiting a group called the CLIMA, C-L-I-M-A model, and MIT is one of the partners in this. MIT does a lot of the surface sea and modeling. This is basically climate modeling. And so the professor at Caltech, who's one of these impossibly brilliant physics types people, is explaining to this, and he's talking about Navier-Stokes equations, and he says, well, we can't model clouds. I said, like, what's wrong with you? Why can't you? It's just not computable. So all of a sudden, we show up with the plug that solves all of his other physics problems because clouds are essential to climate modeling. And so I visited with the team. These are all physicists, and they're impossibly intelligent, obviously. And they're all applying these tools to physics, which for them is relatively simple. And I thought, I got it. We had to build this basic set of platforms. They had to then plug it into their model. Another Caltech example is that there is a set of problems in chemistry which involve relaxation of energy state to find the lowest energy state that then produces the right chemical reaction. Well, all of a sudden, a bunch of graduate students figured out you can use these libraries to do it. So all of a sudden, everyone at Caltech was doing it. That's progress.
Like I said, we're smarter.
I'd like to maybe take a question from the online audience. I have about 50 questions here, so I'm having a hard time picking one.
50 questions in 4 minutes.
I know. I was like, oh gosh. Okay, maybe we'll just pick this one. For a long time, AI has been regarded as a collection of separate studies based on entirely unrelated separate principles. I wonder if anything like a general purpose AI is emerging.
Well, I think what's happened, as much as I agree with Eric that deep learning is going to hit its limits at some point here, as everything does. I think the extent to which deep learning, much of the application of which actually started in computer vision in my area of research, has developed such that it's usable across a wide variety of domains. If that's not the closest thing to a common approach, I'm not sure what is. So I think in some ways many people in machine learning research today sort of bemoan the fact that it feels very sort of like everybody's kind of developing the same algorithms and then applying them to a lot of different problems, and we've sort of lost the diversity of very different ways of looking at machine learning and AI problems. But again, as Eric was saying, I think these things go in cycles. And we'll hit an end, and then there'll be a time period where there's a big diversity of approaches again.
I mean, 25 years ago, people were working on alternatives to CMOS in chips, and then for many good engineering reasons, CMOS took over. There are still tiny pockets of people who are not working on CMOS in universities somewhere in the world, but it sort of essentially eliminated all variation for a while. And now as CMOS begins to hit its natural limits, those people have an opportunity again. And my guess is that's what's going to happen with deep learning. I remember 15 years ago this is again before 2011, people would explain all these AI theories and symbolic language analysis and so forth and so on. And I go, okay, fine, whatever. But that has essentially been completely usurped by these new technologies over a decade, which is a relatively it seems like a long time to you all as students and faculty here, but it's actually a short time in human history for such an extraordinary transformation.
One more question. I'm like, we want MIT students to pursue inventions and breakthroughs fearlessly. On the other hand, we also hope they can slow down, ask why, and think about social and ethical responsibilities of computing. How do we strike a balance? How do we mentor them?
Nice, easy ending question. So, I mean, one thing that I think is very important, and actually this is something that Eric and Wendy Schmidt have been very involved in generally, is how do you train people in more than one discipline, right? So the Schmidt scholars in the sciences is, postdoctoral scholars who do a postdoc in a lab different from where they did their PhD. And I think that today, to really dig deeply into the social and ethical questions around computing, you need to do something like that. You need to say, I got my CS PhD, I'm going to spend a postdoc, working in a scholarly fashion in some discipline in the social sciences or humanities. I think that right now we don't have that level of expertise without that kind of cross-training.
Mm-hmm.
We had one question from the audience.
Hi, thank you so much for the content so far. I guess it might be the last question today, so I'm going to try and phrase it well. I'm wondering, I guess maybe there's two parts to this question. One, I'm wondering how you imagine an ideal human future. And second of all, what were your goals behind writing this book? And how may or may not it relate to, I guess, Eric Schmidt, your work with the National Security, NCSAI, National Security Commission on AI?
I think the utopian future goes something like this. Humanity has spent so much of our time dealing with basic needs and fighting with each other. So if you look at history, it's basically farming, the development of modern economics, and war, right, roughly speaking. And so you could imagine a situation where the end state, this is when your son is elderly, probably hard to imagine, but it will happen, that you could imagine this scenario that the needs of the average person are largely met through improvements in food and material science. Housing is inexpensive, at least a construction perspective, because of all of these developments that are going on here at MIT and elsewhere. And that people are free to pursue more things that are interesting to them. And that the other thing that happens with AI is we learn how to educate people. I would argue that we haven't talked about the impact of AI on education because we haven't seen it yet. But it makes perfect sense to me that AI systems should be able to figure out how you learn and allow you to learn in the most efficient way. And that should be true for every single human being on the planet, and it should be free. I defy you to argue that that's a bad thing. Right? It's got to be good, right, for humanity. So in that sort of utopian view, we'll still fight because we like to fight over things, but we'll fight over things which aren't dangerous and that we aren't harming people and things like that. And that's a really good way to understand this. The work of the book essentially paralleled the work of the commission, because in the commission we talked about basically how to make sure that AI was part of our national security strategy in the United States. We made lots of recommendations, most of which involve building talent. The government is slow to, there's this huge gap between the talent here and the talent in the government. Daniela, who is here, runs a whole program with the military. There's an Air Force group at Lincoln Labs and so forth. And there's lots of really smart people who are working on it, but there are immigration people sending into the military to bring their understanding of AI up to this new standard.
I guess maybe I'll get the last word. So to me, the book, so first of all, I totally agree with what Eric said, and I'm a terrible futurist, so it's good to work with somebody who can see the future better than I can. But I think to your question of the objective of the book, it really was to get people thinking about AI in broader terms. I think that people come at it either with a utopian view or a dystopian view, but the reality is going to be somewhere in between. People come at it with either a technological understanding or a lack of technological understanding. And so the idea was really to try to set these changes in the context of hundreds of years of humanity and provide that as framing to have more discussion of the kind that we've been having here today. And I hope that all of you will continue to do that. It's really important. And your generation is the one that's going to do that more than ours.
And let me finish by saying that it's a privilege to be here. It's a privilege to be, crazily, they made me a visiting professor here, for which I'm ill-suited, but I'm very grateful. And the quality of the talent in this institution is so great that you should be able to win. So what I need you to do is I need you to work harder, work faster, take advantage of this. These things don't occur that often in life. This is this period where this enormous sort of Cambrian explosion of ideas. There are going to be enormous winners in this. And you all, to the degree that you can shape them in the values that we're trying to represent here, are really crucial. Small teams can have an outsized impact. We've seen this in many, many areas. And I would suggest some things to work on. I think I mentioned the education one. Somebody's going to break through this. There's a school of education here. There's a bunch of people working on it here at MIT that I've been working with. Somebody's going to figure out a way to do this at scale. That will have a huge impact, right? Working on underlying algorithms, figuring out a way to generalize these algorithms so they apply across all these fields, and then applying them in each field in a clever way to really deliver breakthroughs. And this means, and when I talk to normal people as opposed to tech people, normal people said, I just can't take it. There's so much going on. And I said, you haven't seen anything yet. We're at the beginning of the power of these tools to transform science and business and society. But it's up to us how that happens. And frankly, it's up to you how this happens. And that's why it's such a privilege to work with you and the other teams that I've had a chance to work with here at MIT.
Thank you very much. I have much more to ask and talk about, but we're at the top of the hour. So thanks very much for the fantastic conversation. Thanks everyone for joining us, and stay healthy more than anything. And thank you.
Thank you.